Hello friends, welcome to part 3 of Mathematical Physics C5 paper solution of Dibrugarh University 2021 third semester. And in 1 and 2 we have already solved up to question number 4, and in this video we're going to solve from question number 5. Okay, so before we start, please subscribe the channel, also hit the bell icon so that you get notified when new video will be uploaded, and share with your friends, hit the thumbs up button as well, and help me to grow my channel. Okay, so now let's start. So here is the question number 5a. Find the absolute error, relative error and percentile error when this number is rounded off to 4 significant digits. Now you see 7 5 4 1 2 6. Here you see what do you mean by significant digits? In a number, all the non-zero digits are significant. So these numbers are all the non-zero digits are significant. So in order to rounding off to 4 significant figures, so we have to keep only 4 significant figures. Here how many digits are there? 1 2 3 4 5 6. There are 6 figures, so we have to keep only 4 significant figures from the left hand side. Okay, then we will make the other two 0. Okay, so we're gonna round up this way: 5 4 1 0 0. So here you see, if this number is 5 or greater than 5, then we're gonna make this digit one more. That means we're gonna add 1 here. Now you see, let me explain it again. As we have this number 7 5 4 1 2 6, and we want to round it off to 4 significant figures, so we have to keep 4 non-zero digits from the left hand side, and we have to make other two zeros, and trailing zeros are not significant. Okay, that means zeros at the end of the number are not significant, but 0 between two non-zero numbers is considered as a significant figure. But trailing 0, that means 70 80, these are trailing zeros. That means 700, here you can, these are also trailing zeros. So in 700 70 80 8000, so number of significant figures is only 1. Okay, so hope you have understood this. So now here we see, so we're gonna round up to this digit. So in order to round up, just you have to see this figure, the digit on the right side of the digit. Suppose we need to, here you see, we need to round it off to digit 1. So we have to check the digit on the right hand side of the 1 is greater than 5 or equal to 5. And if it is equal to 5 and after 5 there is no digit, then we're gonna keep this 1 as 1. And here you see, if it is less than 5, we're gonna keep the 1 unchanged. So here we have 2. Okay, after 1 we have 2. 2 is less than 5, so that's why we're gonna keep we're gonna round it off like this, right? Suppose you have a number like this, suppose 7 5 4 1, you have suppose 5 7, right? So then this is 5 and there is a non-zero digit, so then you have to round it off like this. For this, 1 should be 2, 1 should be added to this digit. Okay, so in order to get 4 significant figures, right? So hope you have understood this. And one more thing, suppose you have no non-zero digits here. After 5 you have 0, suppose you have 0. Okay, then 4 1, though it is 5, you see, though this is 5 and after 5 there is no non-zero digits, there is 0, so that's why we're not gonna add 1 with this digit. Okay, we simply keep it like this way, right? So hope you have understood this. Now let us solve this. So this is the given number, let me round it off: 7 5 4 1 2 6. So rounding off to 4 significant figures, rounding it off to 4 significant figures. we get, what do we get? 754100. So now we have 4 significant figures only, right? So now let's find absolute error. Absolute error, that is equal to mod of my 754126 given number and the number which is obtained by rounding of the given number, right? The difference is the absolute error, and here we're gonna use modulus. That means we are not gonna take negative sign. Okay, so here 26 is the absolute error, and we're gonna find now relative error. So that is given by absolute error by the given number. That means 26 divided by 7,54176. That's what we can have. So you can divide it, and what will be done? So if we divide 26 by this given number, then we should get 0.0000345, approximately this much. Okay, so now what we're going to find? We're going to find percentile error. Percentile error is that here you see relative error into 100%. That's going to give you percentile error. So that means 0.0000345 into 100%, and that's going to be equal to 0.00345% approximately. So this is the percentile error. So hope you have understood this. So that's how we can find absolute error, relative error, and percentile error. So now let's go to the next question. So here you can see, so this is given u is equal to, let me write what is given here. U is equal to 5x cube y to the power 4 divided by z to the power 5. That's what we have here. And now error in x, y and z is given 0.001. okay, that means error in x means del x, error in y means del y, and error in z means del z. That is equal to 0.001, this much. Okay, and also given x equal to y is equal to z is equal to 1. That is also given. Okay, so we need to compute relative maximum error when these are equal to 1. Okay, so relative maximum error. So how to find that? So relative maximum error is given by del u by u. Okay, that's gonna give you relative maximum error. So in order to find that, we must find del u max. We must know this. Just wait. Okay, how to find it? So how to find del u? So this is equal to del u by del x, partial del x of u, partial derivative of u with respect to x, and delta x here, then mod plus again mod of del u by del y, delta y here, then again mod of partial derivative of u with respect to z, delta z here. So that's what we will get. So what will be del u by del x? If you differentiate it, then what you will get? Del u by del x is equal to, so when you do del u by del x, then you have to think, you must consider del y is a constant and z is also constant. Okay, so only variable is x cube. So in that case, it is gonna be 15x square, then y to the power 4 by z to the power 5. If you differentiate x cube ddx of x to the power 3 thrice x square, right? But here we have 5 3s are 15, and then x to the power 4, this is x to the power 4 divided by z to the power 5, z to the power 5. So hope you have understood this. So now what's going to be the del u by del y? Now in this time we're going to keep we're going to take y to the power 4 as a variable and remaining terms as constant. Then in that case, here you see, if you differentiate y to the power 4, that's going to be 4y cube, and 4 5s are 20, so that's why that's going to be 20 x cube y to the power 3 then divided by z to the power 5, right? Now what if we find del u by del z, del u by del z, and if you differentiate this, so here you can see that u can be written as 5x to the power 3 y to the power 4 and z to the power minus 5. We can write that way. So in that case, if you differentiate this, then it's going to be minus 5 and 5 minus 25, then x to the power 3 y to the power 4, then z to the power minus 5 minus 1, that's going to be minus 6, right? That is what we have got. So that means this whole thing divided by z to the power minus plus 6, right? We can write that way. So if we use this result here, let us use these results here, then what we're gonna have, we're gonna have 15 x square y to the power 4, and one more thing, most importantly, just wait, let me keep it, just wait. Here one more thing is given in the question, that x y z equal to 1, right? X y z equal to 1. So if we use this value x y z equal to 1 for x comma y is equal to z is equal to 1, so this is going to be equal to 15, this is going to be equal to 20, right? And this is going to be equal to minus 25. That's what we're gonna have, right? So now, so this is gonna be 15 into del x is nothing but, you know, this 0.001, then plus del u by del y, this is minus 20. Similarly put du by dy, and so we have got this value. So here we have put this du by dy and del y value of del y, here it is this, and du by dy, du by dy, del u by del y is 20, and so on. Now let's put this value, putting these two values of these two, we have got this. So here you see this is the value of this one, right? And del z is again this. So now if we calculate those multiplications and addition, and then what we're gonna have, so we're gonna have this result, right? And then let me go to the new slide. So here you see this is u, this u was given, and on putting x equal to y equal to z equal to 1, we have got 5, u is equal to 5. So and also we have got you know, mod of del u is this is mod of del u, right? And here you see, so how to find the maximum relative error, so that can be found out by using this formula. Here you see, if we use this, here you can see, just wait. So relative maximum error is mod of del u by u. That's what we can. This is what we needed to find relative maximum error. So del u is 0.06 and u we have got 5, and if we divide this, then what we're gonna have 0.015. Sorry, not 52. So this is our answer. So hope you have understood this. So now let's move on to the next question. Next question. Actually, I have no about this. I have no idea about this law and of error. So I have checked many books, but I haven't got the proper answer of this question. So sorry for that. So if you know, then please let me know in the comment box. So now let's move on to the next question. So here, question number 6. Solve any two of the following partial differential equations by method of separation of variables. So we're going to apply separation of variable method in order to solve this any two questions out of these three, but I'm going to show all these three. Okay, so now let's start. So what is the first equation? This is the first equation. Second order partial derivative of z with respect to x minus 2 first order partial derivative of z with respect to x, then partial derivative of z with respect to y is equal to 0. So this is the first equation. Now let me copy this and let me go to the next slide. So here is the given equation. Okay, so let me write here solution. So this is the given equation. Now you see, so in order to solve this, let z is equal to, so here we have two variables, one is x, another is y, x and y. So let us take capital Z is equal to capital X into capital T. Okay, sorry, not T, Y, capital X into capital Y. So where capital X is a function of small x and capital Y is a function of small y, right? So we're going to take that way, and this is suppose equation number 1, right? This is equation number 1. So this is equation number 1. So now let us differentiate partially. Now let us differentiate z with respect to x. Okay, then what we're gonna have, then we're gonna take y as a constant, then we're gonna get this derivative of capital X with respect to small x. Then if you differentiate it again, then you're gonna have second order derivative of z with respect to x, small x, that's gonna be equal to, then again here y should be taken as constant, then second order derivative of capital X with respect to small x. That is what we're gonna have, right? So now you see, similarly we can differentiate z with respect to y as well, then we must do that. Okay, so here you can see, just let me adjust it. Okay, so now second order derivative, sorry, not second order, first order derivative of z with respect to small y. Now this time we're going to take x as a constant, and in that case capital X is taken as constant, then d capital Y by d small y, that's what we're going to have, right? Now let us use these results in this given equation. Okay, so using this expression, using these results in the given equation. So if you replace this term by this result, right? So if you put this one here, then what you're gonna have, this equation look like something like this. Here you see capital Y, second order derivative of capital X with respect to small x, right? Then minus 2, this should be replaced by this result, right? And if you do so, then what you will get, capital Y dx d capital X by d small x, then plus, and last time this should be replaced by this result, then what you gonna have, capital X dy by d small y is equal to 0. That's what we're gonna have, right? So now let me separate the variable. So before that, let me write this equation in this way. you can write this one, you can represent this one in this way, x double this, and you can write this one as x dash, and x, we can write this as y dash, right? So x double dash means second order derivative of capital X with respect to small x, and x dash means first order derivative of capital X with respect to small x. Similarly, y dash is equal to first order derivative of capital Y with respect to small y. So let us represent that way, is equal to 0. Now it becomes easier to separate the variables. So here you see we can take y common, right? Taking y common, we have got capital Y x double dash, capital X double dash minus 2 x dash, and let us transfer this to other side. Then what you're gonna have, minus capital X capital Y dash, right? So here you see what you can have here. Now separate the terms containing x and y, and doing so what we're going to have in the next step. So let me write these things here. Okay, so in the next step what we're going to have, we're going to have 1 by capital X x double dash minus 2 x dash, and on the other side we're going to have minus 1 by y and y dash. Okay, now let us consider each part of this equation be equal to a constant, that suppose let it be k. Let us consider that constant be k. So we can say that this part is equal to k and this part is also equal to k. So now let us take the first part only. Now we can write 1 by capital X double dash minus 2 x dash is equal to k. Now let me copy this and let me go to the next slide. So here you see, so this is the last equation we have got. So in this case we can take we can multiply both sides by x, capital X, then this equation becomes of this equation becomes of this form. Then if you bring this kx to the left side, then it becomes minus kx. So minus kx is equal to 0. That is what we're going to have. So we can write d square minus 2d minus k into x is equal to 0. So here you see x double dash, we know that the second order derivative of capital X with respect to small x, right? And if you take this x here, then it is represented by d square. Similarly, this d represent this d x small x, right? And this x is taken outside, right? So hope you have understood this. Similarly, this x is also taken out here, right? So hope you have understood this. Now our auxiliary equation is m square minus twice m minus k is equal to 0. Now it is a quadratic equation. So what we can do, just wait. So we can apply the quadratic equation formula. Sorry for this. So what was the formula to solve a quadratic equation? Just so that's going to be that's minus m is equal to minus b. B is here, minus 2 is b, this is c, and the coefficient of m is a. So here in this case 1. So minus b, here it is minus 2, then plus minus 2 plus minus root over 4ac, minus b square 4ac. So this was the formula, minus b plus minus root over b square minus 4ac divided by 2ac, right? So here a is 1, c is minus k, okay, and b is minus 2, and a is 1, right? If we put those values instead of x, we're gonna have m here. So, and doing so, what we're gonna have, we have here minus 4 into a is 1, c is minus k, and divided by 2, I say 2 into 1. That's what we're gonna have. Now if we evaluate this, here it is 4 minus plus 4k, right? If you multiply these two, minus, that's going to be plus, right? Divided by 2 by 1, 2 into 1 is 2, right? Now you can take 4 common, so in that case 2 plus minus 4 is taken common, then and square root of 4 is 2, so that's why 2 is taken outside, so 1 plus k left under root by 2, and again if you divide the denominator by 2, then you're gonna have 1 plus minus root over 1 plus k. So here we have got the two roots, and those are, you know, m1 and m2. Here what we have got, let me split this screen here. Okay. So what we have got, m1 is your 1 plus root over 1 plus k, and m2 is 1 minus root over 1 plus k. So these are m1 and m2 here belongs to z. These are real, sorry, not z, are real and distinct. m1 is not equal to m2. So in that case, the complementary function is given by c1 e to the power m1x plus c2 e to the power m2x. So hope I know you know these conditions when you have to use the, when you have studied differential equation, you must have got those conditions when the roots are equal, when the roots are distinct, and when the roots are imaginary. What is the cumulative frequency, sorry, complementary function should be used here. Okay, so in case of real and unequal roots, this is the complementary function, and the solution of this equation will be given by x is equal to cf plus pi, and in this case pi is equal to 0, as there is no function on the right hand side. On the right hand side we have got 0, so pi is also 0 here in this case. So only cf gonna give you the answer. So that's why what we have got. So our answer will be c1 e to the power m1 is 1 plus root over 1 plus k into x. This is m1x. Sorry, that should be capital X, I think. Not capital X, that should be small x. Okay, small x. Then plus c2 e to the power 1 minus root over 1 plus k into x. That's what we have got. This is one part of the solution. Now let me go to the other part. Here you see, let me go to the previous slide. Now let us take this part. Okay, so now let me copy these things. Just wait. And let me go to the new slide here. So here you see, this is what we had. Again, now it gives y dash, capital Y dash minus ky, and this equation becomes capital Y dash plus ky. Just let me keep this way only, right? So this can be written as, capital Y dash means d capital Y by small y minus k capital Y. Okay, and now here you see what we can write here, and we can write 1 by y. This y dash is d capital Y by d small y minus k. We can write that way. Then this also can be written as this, right? Then we get this. Okay, so hope you have understood this. So now we get this equation, right? Because here you see this is d capital Y by d small y, right? So small y is taken to other side, right, in order to integrate. Now if we integrate both sides, so integrating both sides, then what you will get? So integrating both sides, let me copy this. So let's integrate now. K is constant, so it can be written outside the integration. Then what you will get? So 1 by y dy, that's going to be log of y, log of capital Y, and on the other side minus k. Integration of dy is simply y, here it is small y. That's what we have got, right? And we're gonna need an integrating constant also. That let it be suppose c3. As we have log here, let me take log c3. Okay, let me take log c3. Now remember, log of e to the power x, where base is e, is x only. So that's why this term can be written as log of e to the power minus ky. Okay, so that's gonna be that gonna be helpful for simplification of this equation. That's why we're gonna write that way. So that's what we're gonna do here. Log of capital Y is equal to e to the power log of e to the power minus k y small y plus log of c3. And as there is plus, we're going to apply this rule, log m plus log n, that is equal to log m into n. Okay, so if we apply that rule, then this equation is now log of capital Y log of e to the power minus ky into c3. That is what we have got. So we can remove the log from both sides. So then we can write capital Y is equal to e to the power minus ky c3. That's what we have got. So now let us use these solutions. One solution is for x, this one here, and this solution in equation number 1. Let me take this as 2 and this is 3, and using 2 and 3 in this equation number 1, then we're going to get z. That is our solution, complete solution. So using, just let me write the 3 equations here. Now let us use these 2 equations in this equation. Okay, and let me write using 2 and 3 in 1. So then we're going to get the desired solution. Now the solution is z is equal to c1 e to the power 1 plus root over 1 plus k into x, then plus c2 e to the power 1 minus root over 1 plus k into x, and this whole into c3 e to the power minus k small y. That's what we're gonna have, right? So hope you have understood this. So this is the solution. So hope you have understood. Now let's go to the next question. So what is the next differential equation? So this is the next differential equation we're going to solve here. Okay, let me show you how to solve. This is very simple. Now let us solve this equation. Okay, so here you see again we're going to consider that u is equal to product of capital X and capital T. So as we have two variables x and t here, and you see here capital X is function of small x, and capital T is a function of small t. That's what we have taken here, right? and let us take this one as equation number 1. Now let's differentiate it with respect to x. Del u by del small x, right? Let us differentiate it with respect to small x. Then we're gonna take t as a constant, capital T, then d capital X by d small x. And if we differentiate it again with respect to t, then what we're gonna have, del u, second order derivative of del u here with respect to x and t, right? Del square u by del x del t, and this time we're gonna take x as a constant. In that case, what we're gonna have, so here this terms remains as it is, then here we're gonna have d capital T by d small t into d capital capital X by small x. That's what we're gonna have, right? So that's what we have got. Okay, so now let us use this in the given equation. Okay, if we use this equation, this result using 2 in the given equation. So given equation means this one is the given equation. So here I have used this result. Okay, so hope you have understood this. This is used here, right? So now using that, what we're gonna have derivative of capital T with respect to small t into derivative of capital X with respect to small x is equal to e to the power minus t cos small x. That's what we're gonna have, right? So now again we're gonna separate the variables, t on one side and x on other side. In that case, so e to the power plus t d capital T by d small t and cos x by d capital X by small x d small x. So that's what we're gonna have. So let it be k. Let us say this two are equal to k. So in this case we're gonna take the first part, this one is equal to k. So let me divide the page here. Okay, just wait. So let me write these things in a box. Now e to the power t d capital T by d small t is equal to k. Then what we're gonna have here, so if you simplify this, you can write this in this way, d capital T, this can be written as d capital T k into e to the power minus t, right? E to the power minus t d small t. That's how you can write. Now if you integrating both sides, right? What we're gonna have, if you integrate both sides, integration d capital T, k is taken outside as it is constant, integration e to the power minus t dt, right? So integrating this, what we're gonna have, integration of d capital T, that's gonna be capital T, then k e to the power minus t divided by minus 1, so which can be written as minus k e to the power t, and there must be an integrating constant, let it be c1. Okay, that's what we have got. So this is suppose equation number 3. Let it be equation number 3. Okay, so now again this part, again what we can write cos small x by d capital X by d small x is equal to k. So here what we're going to do, from here we can write d capital X is equal to 1 by k cos small x d small x. we can write this way. If you simplify, you may check yourself, if you simplify this equation, you can get this result, right? So that's what we're gonna have. Now if you integrate both sides, okay, if you integrate, integration d capital X is equal to 1 by k is constant, again integration cos x, cos small x d small x, then integrating it, what you're gonna have, you're gonna have integration of this will be capital X, and integration of cos x is simply sin x, so 1 by k sin x plus integrating constant, let it be c2. So this is equation number, suppose 4, right? This is equation number 4. Now let us put this equations, let us use this 3 and 4 in equation number 1, in this equation, this is equation number 1. So let us use this 3 and 4 in 1 to get the solution, complete solution, using 3 and using 4 in equation number 1. So what we're gonna have, we're gonna have u, so you can write this u as a function of x and small t also, you can write that way as well. So capital X is this, so here you see this is the result of capital X, this is the result of capital X. So let me write the capital X result first. This is the result of capital X, then this is capital T. From equation number 3 we have got capital T, right? So here you can see, so this is the result of capital T. So this is the solution. Now let me copy this and let me go to the next slide. Okay, next slide. So this is our result now, that's what we have got. Okay, so what are the given conditions? So here you can see, so these are the given conditions. Let me copy those conditions and let me go to the next slide. Okay, here you see, so these are the given conditions. Now it is given that when t is equal to 0, u is equal to 0, u is equal to 0 at t is equal to 0, small t is equal to 0. So then what if you put t is equal to 0 here, that means u x t is equal to 0, then if you replace this t by 0, then your function, this result gonna be something like this: 1 by k sin x plus c2 into e to the power 0, that's gonna be equal to 1. So here we're gonna have minus k plus c1, that's what we're gonna have, right? So hope you have understood this. Now you can see at t equal to 0, u is 0, so we can replace this by 0, and then we can write that 1 by k sin x plus c2 into minus k plus c1 is equal to 0. We can write 0. Okay, so this is the value of u, and this is also value of u at t equal to 0, that's why we can write this. Okay, so now you see this part cannot be equal to 0, that's why minus k plus c2, sorry not c2, c1 is equal to 0, since 1 by k sin x plus c2 cannot be equal to 0, right? Okay, as we have variables here, so we are not sure that what it's gonna be, so now we can take this as a 0. Now you see from c1, so from this equation we can find c1, which is equal to plus k, right? So we have got plus k. Now let us differentiate this equation. Let it be equation number, suppose what was the last equation, number 4. So now let me take this equation number as 5, and now if you differentiate this equation number 5, okay, now differentiating equation number 5 with respect to t, because here we have one more condition: at x is equal to 0, del u by del t is equal to 0. So let's find del u by del t. then what you will get? Del u by differentiate with respect to small t, then terms containing x must be taken as constant. So in that case, 1 by k sine x plus c2, and if you differentiate this, then what you're gonna have, then derivative of e to the power minus t, that's going to be minus e to the power minus t. So minus, and there is one more minus, it's going to be plus k e to the power minus t, and derivative of constant is 0. So we're going to get this, right? So hope you have understood this. Now here you see, so at x is equal to 0, so du by dt is equal to 0. And what we have got, du by dt is equal to this. So if you replace this by this expression, then what you will get? 1 by k sine x plus c2 into k e to the power minus t is equal to 0. That's what you will get, right? So then here you see, and here you see, this is equal to 0 when u is equal to x is equal to 0. So now here we can change, sine 0 is 0, so that is why here you see, just wait, I made a mistake here. Now you see, at x is equal to 0, this term should be 0 because sine 0 is 0. So that's why we should get here c2 into k e to the power minus t is equal to 0, and from here we can say that c2 is equal to 0. This implies c2 is equal to 0, right? Sorry, and this is going to imply c2 is equal to 0. c2 is equal to 0. So we have got the value of c2 and c1. Now putting this value in equation number 5. Okay, if you put the value of c1 and c2 in equation number 5, then you're gonna get the complete solution. Okay, so now what we're gonna do, putting c1 is equal to k and c2 is equal to 0 in equation number 5, we're gonna have u is equal to 1 by k sine x plus c2 is 0 and minus k e to the power minus t. c1 is your k, right? c1 is k. So in that case, what we're gonna have here, so 1 by k into sine x, and from here you can take k common, into k, okay, into k, then 1 minus e to the power minus t. That's what we're gonna have. This is k, right? And this one cancel. So our result is 1 minus e to the power minus t into sine x. So this is our answer. So this is the required solution. So hope you have understood. Now let's move on to the next question. Now let us solve this question. So question number 6A3. So let me take a slide. Now let us consider u is equal to capital X and capital Y, capital X into capital Y. This is suppose equation number 1, where capital X is a function of small x and capital Y is a function of small y, right? So that's how we have considered. Again, let's find del u by del x. Taking y as constant, we're gonna get d capital X by d small x. And again, if you differentiate it, then you're gonna have second order derivative of partial derivative of u with respect to small x, and now this time it's gonna be y into second order derivative of capital X with respect to small x. That's what we're gonna have, right? Now let's find del u by del y. So del u by del y, del u by del y. So small y with respect to small y, if you differentiate it with respect to small y, then we can take x as a constant now, d capital Y by d small y. That's what we're gonna have. Now using these results in the given equation, in this equation, if you replace this and this by these two results, then what you're gonna have using these results in the given equation, what we're gonna have. So if you replace this part, okay, if you replace this part, then you're gonna have capital Y, second order derivative of capital X with respect to small x, then is equal to, and if you replace this down by this result, then capital X dy by d small y plus 2u is replaced by this capital X and y is equal to 9. This is the equation. Now let's separate the variables. Then what we can do, we can take x common from here, right? We can take x common. So then what we can have, on taking x common, capital X is taken common, so it becomes like this. That's what we have got. So if you simplify this, if you separate the variables, then it can be like this, something like this, 1 by x. So this can be written as capital X double s, right? And as I have already explained how we can write that. So now 1 by y, this y is transferred to other side, so it becomes 1 by y, and this dy by d small y, it can be written as capital Y dash, right? And plus 2 capital Y. That's what we have got, right? So now let us consider, you can multiply with this 1 by y with its term of this expression which is within bracket. Then doing so, what we're gonna have, we're gonna have y dash by y plus 2y is divided by y, then it gives only 2. Let it these two terms be constant, that is suppose k. Okay, so what we have done here, we have you can say like that we have divided the both side by x and y. You can say like that, divide this one by x and y, divide this one by x and y. So that's how we can get this equation. And one more thing, so what we have done here, and we have considered these two, each of them equal to a constant, that let the constant be k. Okay, let that constant be k. Okay, let us say this is called k. So now you see, so let us take this first part, that is 1 by x double s is equal to k. So from here what we're gonna get, we're gonna get this equation, right? And it implies the x double dash minus kx, right, is equal to 0, and it implies that d square minus k into x is equal to 0. So here what we have done, we have as I have already explained, that x double dash means the second order derivative of capital X by with respect to small x, right, with respect to small x. So this x is taken out, and this part is regarded as d square, right? Similarly, from kx, this k is taken out, right? From these two, x is taken out, so we have got d square minus k. So that's how we have got. So now our auxiliary equation will be like this, and d square is replaced by m square minus k is equal to 0. And if you solve this equation, then you're gonna get m is equal to plus minus root k, right? Now if the roots here m1 and m2, that means plus root k and minus root k, there are two roots m1 and m2. These two are not equal, but they belongs to real number, set of real number. So that's why according to those rules that we have studied in differential equations, okay, that if you have clear concept of the differential equations, you must know this. When roots are real and unequal, then CF complementary function is given by this C1 e to the power m1x, that is root kx here, plus C2 e to the power m2x, that means here minus root kx. That's what we used to get. Right now, here you see on the right hand side of this equation, there is no any polynomial, any function of x, or and it is 0, so that's why pi is also pi is 0 for this. And the solution of this equation, this equation, that's going to be x is equal to cf plus pi is 0, so that's why our solution will be this is going to be the solution of this equation. Right, so we have got the solution for this equation. So now let us take the next part, this part. Let me take a new slide here. So let me copy this part here, you can see. Just let me copy this and let me take a new slide. Okay, just wait, give me a few seconds. Here you can see. So this is what we have got in the next part. So here you see, and this is going to be equal to 1 by y, and this is what d capital Y, d small y, k minus 2, right, and 1 by capital Y, and d capital Y, k minus 2 into d small y. And if you integrate both sides, then what you're gonna have? So integrating both sides. Now let us integrate both sides. Here this part is constant, so taken outside. So if we integrate this, then we're gonna get log of capital Y, then k minus 2 into small y. That's what we're gonna have, right? And there must be a integrating constant. So as we have log here, so let the constant be log of c3. Let me consider that way, right? So now you see, we know that log of e to the power x is x, right? So that's why we can write this term as log of e to the power k minus 2 into y. That's gonna be again this, right? So because we have this one in log, so that's why I have to do that way. So now let me clean these things, just wait. So here what are you gonna do? Log of capital Y, log e to the power k minus 2 into small y, then plus log of c3. Now here we're gonna apply log m in, sorry, not m, yes, m plus log n. So according to this, log m into n. So if we apply that identity, log m plus log n is log m into n. In that case, so this is gonna give you this, right? Log of product of these two. So what we have done, we have applied log m plus log n is given by log m into n. So we have used that way. So here you see we can remove the log from both sides, then our result gonna be like something like this: capital Y e to the power k minus 2 into small y into c3. Let me write the c3 here. Okay, that's what we're gonna have, right? So hope you have understood till now. So now you see, now putting the values of capital X and capital Y in equation number 1, putting the values of capital X and capital Y in equation number 1. So what are we gonna get? So what was equation number 1? Equation number 1 is nothing but u is equal to x into y, capital X into y. So what is capital X we have got here? This is the capital X, right? This is the capital X. Let me copy this. And you see this is the equation number 1, right? And capital Y is this. This is the capital Y. Here you see. So you're gonna use this in this equation number 1. This is equation number 1, right? So we have got u can be written as, which is function of x and y, right? Which is, that's going to be capital X is this. We have got this result, capital X is equal to this one. So let me cut this one. So instead of x we're going to put this, and then we have capital Y, and capital Y is this. So that is C3 e to the power k minus 2 into small y, minus 2 into, just wait, here you can see. So this is the solution we have got. Now let it be, suppose, equation number 3. Let us take, this is equation number 3. Now we're going to use the conditions. What are the conditions? Let me go to the question here. So these are the conditions. Here you can see. So I haven't used any equation number 2 yet, so we can give it equation number 2 instead of 3. We can make it 2, right? Just wait, just let me write this one, equation number 2. So here you see what are the conditions we have here. Let me go back to the first slide. Here you see, so these are the conditions. Let me copy these conditions. So these are the conditions we're going to use here. So these are the conditions, right? So now what we're going to do here, just wait, let me take a new slide. Okay, so this is a new slide. So what we have got last, so this is the result we have got, and the conditions are given. These are the conditions. So these are the conditions given. At u is equal to 0, sorry, x is equal to 0, u is also equal to 0. So at x is equal to 0, you know, at x is equal to 0, u is equal to 0, and from this equation number 2, so equation number 2 implies when x is equal to 0, that means you can say x is 0 now, small y, that's going to be equal to, if you put 0 here and here, what you're going to have, you're going to have c1, so anything to the power 0 is 1, plus c2 into c3 e to the power k minus 2 into y. That's what we're going to have, putting here 0. And again, if x is equal to 0, then u is also equal to 0, so we can write c1 plus c2 into c3 e to the power, just wait, e to the power k minus 2 into y is equal to 0, right? So here you see, u is equal to 0 when x is 0. On putting x is equal to 0 here, we used to get, we are getting this result, right? And that must be equal to 0 according to this given condition. So hope you have understood this now, right? So so now this u equal to 0 means u of 0 comma y is equal to 0. Same thing here, this part is not written only, right? So hope you have understood this. So as we have considered u is equal to capital X and capital T, and these are function of small x and capital T, capital Y, these are functions of capital X and Y. So that's why we can say u is a function of small x and small y, because capital X, capital Y are functions of small x and small y respectively. So hope you have understood this, right? So now you see from here, in this case this part cannot be 0, right here. So that's why c1 plus c2, that must be equal to 0, since c3 e to the power k minus 2 into y is not equal to 0. This part is not 0. So here only this is the possible part which can be 0 here. So c1 is equal to minus c2 here. Okay, c1 is equal to c2. So now using this value in equation number 2, right, using, so let it be equation number 3, using 3 in 2, what we will get. So here you see, using this here, if we put c2 is equal to minus c1, then then we're gonna have u is equal to c1 e to the power root k x minus, because C1 is equal to minus C2, so C2 must be minus C1, right? So here we can put C1 e to the power minus root k x C3 e to the power k minus 2 into y. That's what we're gonna have, right? And it can be simplified as, just wait, let me do here. So here you can see this can be written as u is equal to C1 is taken common, then C1 into C3 e to the power root k x minus e to the power minus root k x into e to the power k minus 2 into y. That is what we will get, right? So now you see, now again you see, for value of x we also have one more conditions, that is partial derivative of u with respect to small x is equal to 1 plus e to the power minus thrice y. So that's why let us differentiate this. Okay, so if you differentiate this, then what you will get, del u by del x. If you differentiate it partially, then you're gonna have C1 C3, then if you differentiate this, then it will be root k e to the power root k x, and here this is minus root k, so minus minus plus root k e to the power minus root k x. Then just wait, let me find a space here. Okay, just almost done, just wait, just give me a second. So here we can write e to the power k minus 2 into y. Okay, that's what we have got, e to the power into e to the power just 2x and e to the power k minus 2 into y. So here you see we are differentiating, we are trying to obtain actually we obtained here partial derivative of u with respect to x. That's why this term consisting y is taken as constant, right? So hope you have understood this. Now you see, at x is equal to 0, right, del u del x is equal to 1 plus e to the power minus 3y, right? So at x is equal to 0, what gonna be its value? If we put here x is equal to 0 and here also x is equal to 0, then this term gonna be 1 and this term gonna be 1, then 1 root k, that gonna be definitely 2 root k, right? So at x is equal to 0, so we can write at x is equal to 0, del u by del x at x is equal to 0, it gives C1 C3 2 into root k e to the power k minus 2 into y. That's what we get, right? So, and you see, and at x is equal to 0, and its value is this, right? So that's why we can say that, therefore we can say C1 C3 2 root k e to the power, here one more thing, as there are two terms, this one and this one, so we can say simply, now remember one more thing, that this solution, its general solution can be written as u is equal to summation from n is equal to 1 to infinity un, right? So that's why, or you can say u1 plus u2 so on, right, dot 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 so on. That's why we can write this solution, as C1 C3 root 2 k1 e to the power k1 minus 2 into y is equal to, sorry, not is equal to, plus C1 C2, not C2, C3 2 root k 2. Here it was k1 and now it should be k2, and e to the power k2 minus 2 into y. We can write that way. So just wait, let me go to a new slide. Okay, not enough space here. Just let me copy these things and let me go to a new slide. So here you see, this is what we have got. Now you see this del u by del x, it can be expressed as at x is equal to 0 at this condition, c1 c3 2 root k1 e to the power k1 minus 2 into y plus c1 c3 2 root k2 e to the power k2 minus 2 is equal to into y, right? We can take that way, and here you see actually this can be written as del u1 by del x plus del u2 by del x, right? We can consider that way. And here you see here, from here you can compare this one as del u1 x and this is del u2 x, del u2 del x, right? So here you see this can be written as del u1 del x plus del u2 del x is equal to 1 plus e to the power minus thrice y. You can compare that way, and this one can be written as e to the power 0 minus thrice y. So if you replace these two by this, what we can get? So we're gonna get c1 c3. So just let me copy these things and let me write here. Okay, so this is what we're gonna have. This is equal to this. We're gonna get this, right? So now compare. If we compare with this one, then what we will get? C1 C3 2 root k1 e to the power k1 minus 2 is equal to e to the power 0, and this is gonna implies here we can say 1 into e to the power 0. So that's why c1 c3 into 2 root k1 is equal to 1, and on the other hand this power is equal to 0. So that is k1 minus 2 is equal to 0, which is gonna give you k1 is equal to 2, and if you use the value of k2 here, k1 is equal to 2 here, then what you will get? You're gonna have c1 c3 2 into root 2 is equal to 1, right? And this is gonna implies c1 c3 is equal to 1 by 2 root 2. That's what we're gonna have, right? So now you see, now if you compare this term with this, then what are you gonna have? This part gonna be equal to 1, right? We can consider this one as 1, right? So similarly we get c1 c3 is equal to, so not is equal to, 2 into k2 is equal to 1, right? And what we're gonna have? k2 minus 2 is equal to minus 3. That's what we're gonna have. This power gonna be equal to this one, right? That's what we're gonna have. So now here you see, so there was y actually, so you can consider this is 0 into y, you can say that way, 0 into y, you can imagine that way, right? So again 0 into y, that's gonna be 0, and so that's why k minus 1, k minus 2, that's gonna be 0. Here also you see this is gonna implies k2 is equal to minus 3 plus 2, that's gonna be equal to minus 1, right? That's gonna be equal to minus 1, and if you put here minus 1 instead of k2, then what are you gonna have? So c1 c3, So root over minus 1 is I, so that's why we can write here 2I. We can write 2I is equal to 1. So C1 C3, that's going to be I is equal to 1 by 2. Sorry, C1 C3 is equal to 1 by 2I, right? So here we have put K2 is equal to minus 1, and so that's why you see root minus 1 root, okay, you can see root over K2, that's going to be minus root over 1, which is going to be I, right? So we have done that way, so we have replaced this by I. So hope you have understood this. Okay, so in that case, what going to be the result now? So now let me copy these things. Let me go to a new slide. Yes, let me go to a new slide. Here you see, this is what we have got, and as you see, let me go back to previous slide, not this one, this one. Here you can see, as we have got u is equal to this one, let me take this one as equation number 4, right? So as we have already taken 3 here, so now let me take this one as equation number 4. This is suppose equation number 4. So now let me copy this equation, just do it, and let me go to the next slide. Here you can see, so here this is the equation number 4 we have taken. Just do it. Okay, so here let me write equation number 4. Okay, so here you see, let us keep this equation number 4. This is equation number 4, right? From this equation we know u is equal to this. So here you see, u can be written as u1 plus u2. This can be expressed in this way. So in that case, what going to be the u1 using this formula? Okay, using this formula, here you see u1 going to be equal to, if you put for u1 we have to put those values k1 and c1 c3 is equal to this. So if you put c1 c3 is equal to 1 by 2 root 2, then e to the power root k, here k2 k1 is equal to 2, so we're going to put here k is equal to 2 here, so root 2 into x, then minus e to the power minus root 2 into x. That's what we're going to have. Then next, what going to be the u2? So for in order to get u2 we have to put these values here, and here we're going to put now k is equal to minus 2. We're going to put k is equal to minus 2, right? Then we're going to get u2. So that's going to be equal to 1 by 2i. Instead of these 2 we're going to put 1 by 2i, then e to the power minus sorry, this should be equal to minus 1. We're going to put here minus 1, k is equal to minus 1. So as we have minus 1 here, so that if you put minus 1, that's going to be equal to root of minus 1, that is I into x, then minus e to the power, then minus ix. Okay, then that's what we're going to have. And one more thing, I forgot one more part here, that is what that should be, you see there is one more part, e to the power k minus 2. For this one, for u1, if you put k is equal to 2 here, then this is going to be 0, and anything to the power 0 is 1. So we're going to get here this one into 1, again nothing going to be changed, so it's going to remain as it is. So and here we're going to get e to the power, if you put minus 1, that's going to be minus 3 into y. That's what we're going to have. So this is our answer, and you can simplify this as, you see, if you write this 2 here, this is going to be sine hyperbolic, is going to be sine hyperbolic root 2x. That's what we're going to get, right? So let me keep this here only, just do it. So hope you have understood this. Now you see, okay, and this is divided by 2, that is nothing but sin x. Okay, so I'm gonna write the formula here what I have used. So here you can see, so this is gonna be equal to, here 1 by root 2 should be there, and plus e to the power minus thrice y. I have written this one first, then this one will be sin x. Okay, because you see sin x is equal to e to the power ix, e to the power ix minus e to the power minus ix divided by twice I. This is equal to sin x. So I have used this formula, right? So that's how we can solve this. So this is the final solution. So hope you have understood this. So thank you for watching. See you in the next video, and remaining questions will be solved in the next video. So take care. So see you in the next video.